The main purpose of today's discussion is to know how to calculate the friction factor in liquid. This is required for calculation of pressure drop. So let's just start the discussion. Friction factor in liquid. The friction factor is required for calculation of pipe friction losses or pressure drop. Friction factor can be calculated using various methods like Moody chart, Colebrook's equation, etc. However, in this lecture, I will use the Churchill equation for friction factor calculation. Churchill equation is applicable for laminar and turbulent flow. However, this will also provide an estimate for transit flow regime. However, this should be used with caution as accuracy for transient flow regime is not known. Churchill equation for a laminar flow for Reynolds number less than 2100 and turbulent flow greater than 4000 is applied. Friction factor calculated from Churchill's equation is a Darcy friction factor. Darcy friction factor for a laminar flow is also calculated by Darcy's equation, which is F is equal to 64 upon Reynolds number. Darcy friction factor is a 4 times of Fanning friction factor. That means the Darcy friction factor is a larger than Fanning friction factor. Pressure friction pressure loss or head loss is calculated as H is equal to F into L by D into V square upon dg 2g, where H is friction loss in meter, F is Darcy friction factor is constant, L is the length of pipe in meter, D is inside diameter of pipe in meter, V is the velocity of fluid in meter per second, and G is acceleration due to gravity is 9.82 meter per second square. Now, what are the input data required for calculation of friction factor in liquid? So, pipe size and schedule, flow rate, liquid density at operating temperature, dynamic viscosity at operating temperature. And how to find out the friction factor? So, to find out the friction factor, we should know Reynolds number and relative roughness. It is a small e upon capital D. Following steps to be followed: actual flow rate, cross sectional area of inside pipe diameter, that is A is equal to pi into d square upon 4, velocity of liquid through pipe V is equal to actual flow rate upon cross sectional area. Reynolds number as per formula is R into RT into V into D upon mu, where RE is the Reynolds number which is constant, D is the inside pipe diameter is meter, RD is the density of liquid in kg per meter cube, V is the velocity of liquid in meter per second, and mu is the dynamic viscosity in Newton second per meter square. Relative roughness, small a upon capital D, where small is the pipe roughness in millimeter, D is the inside pipe diameter of pipe which is millimeter. So based on the pipe material, roughness is given like commercial or welded steel pipe to 0.045 millimeter, cast iron 0.26 millimeter, steel new 0.045 millimeter, steel lightly corroded 0.3 millimeter, steel heavily corroded 2 millimeter, steel stainless steel drawn tubing 0.002 millimeter, PVC pipe 0.0015 millimeter, concrete pipe 0.3 millimeter. Churchill equation for Darcy friction factor for Reynolds number less than 2100 and greater than 4000. Churchill constant A is equal to 2.457 into natural log ln into 1 upon 7 by Reynolds number to the power 0.9 plus 0.27 into a small e upon capital D bracket close to the power 16. Churchill constant B is equal to 37530 upon Reynolds number to the power 16. Friction factor as per Churchill equation F is 8 into bracket start 8 upon Reynolds number to the power 12 plus 1 upon A plus B to the power 1.5 bracket close to the power 1 upon 12. where F is Darcy friction factor, which is constant, A is a constant for Churchill equation, B for constant for Churchill equation, R is Reynolds number, which is a constant. So oil is flowing through the welded steel pipe having 4-inch schedule, 40 inside diameter is 4.026 inch, with flow rate of 400 liter per minute. Density and viscosity of oil are 850 kg per meter cube and 32 cp respectively. Calculate the pipe friction factor. So input data, flow rate is given Q is 400 liter per minute. Pipe inside diameter D is 4.026 inch. Density of oil RD is 850 kg per meter cube. Dynamic viscosity mu is 32 cp. Calculation. Flow rate Q is 400 liter per minute, which is equal to 400 divided 1000 into 60 is meter cube per second. On calculation it comes 0.0067 meter cube per second. Inside diameter of pipe D is 4.026 inch, which is equal to 4.026 into 25.4 or millimeter divided by 1000 is equal to meter, which is coming as 0.1022 meter. Cross section area of the pipe A is pipe and D square upon 4, which is coming as 0.0082 meter square. Liquid density of pipe A is Q by A, which is 0.0067.0.0082, which is 0.81 meter per second. Dynamic viscosity of liquid mu is 32 cp, but 1 centipower is equal to 0.001 meter second per meter square. So dynamic viscosity of liquid mu is 32 into 0.001, which is coming 0.032 Newton second per meter square. So Reynolds number RD into V into D upon mu is 850 into 0.81 into 0.1022 upon 0.032, which is coming as 2199. Pipe roughness based on the pipe selected is 0.045 millimeter. Relative roughness small e upon capital D is equal to 0.045 upon 4.026 into 25.4, which is coming at 0.00044 constant, which is constant. Churchill equation constant A 2.457 into natural log of 1 upon 7 upon Reynolds number to the power 0.7 plus 0.27 into small e upon capital D bracket close to the power 16. By putting the data, it is coming as 4.4 into 10 to the power 17. Churchill constant B is equal to 37530 upon Reynolds number to the power 16. Putting the value of Reynolds number is coming 5 from 0 into 10 to the power 19. Friction factor as per Churchill equation F is equal to 8 into 8 upon Reynolds number to the power 12 plus 1 upon A plus B to the power 1.5 bracket close to the power 1 upon 12, which is coming 0.0301. So in calculation summary, liquid flow is 400 liter per minute, density is 850 meter kg per meter cube, dynamic viscosity 32 cp, pipe inside diameter is 4.026, pipe roughness based on this pipe is 0.045 millimeter, cross section area of the pipe 0.00282, 0.0082 meter square, velocity of liquid in pipe 0.81 meter per second, dynamic viscosity in Newton second per meter square is 0.032, Reynolds number is 2205, relative roughness small e upon capital is 0.0004, Churchill constant A is 4.4 10 to the power 17, Churchill constant B is 5.0 10 to the power 19, and friction factor is 0.0301. So that's a friction factor as per Churchill equation is 0.0301. Now we have to see Darcy friction factor using the Churchill equation and using the Darcy equation for the laminar flow. So you can use this with an example. Oil is flow through welded steel pipe having pipe size 4 inch schedule 40 s, pipe inside diameter 4.026 inch with flow rate of 400 liter per minute. Density and viscosity of oil are 850 and 36 cb respectively. Calculate the pipe friction factor using Churchill equation and Darcy equation. So So this is Churchill equation and this is Darcy equation for laminar flow. So Q is 400, RD is 850, MU is 36 now. So based on the calculation, it is coming 0.0327. Now Darcy equation for laminar flow less than, since now Reynolds number is 1960, so it is less than 2100 is laminar flow. So Darcy friction factor can be, Darcy friction is equal to F is equal to 16 by Reynolds number can be used because it is laminar. So small f, it is wrongly written capital F, it should be small f, is equal to 64 upon 1960, which is coming at 0.0327, which is exactly same. Note, the Darcy friction factor is same for both Churchill and Darcy equation for laminar flow. So thank you. With this I have finished my lecture. Hope you will like this. If it is so, please subscribe my channel, like it and share it so that you can get the information of new video. See you with a new discussion. Till then, bye bye. Thank you.